Hi, everybody. My name is Marty Gubar, and I'm from the Big Data SQL and Cloud SQL product management team here at Oracle. We're going to be taking a look at how to create a bridge from the data warehouse to the data lake, and how to do it in a best practice way using the latest Oracle platform capabilities for both efficient processing and centralized management. And really, the ultimate goal is to make it easy for you, for organizations to gain insights from all your data, regardless of where it may reside. Now, if you have questions throughout this talk, feel free to ask them via the Q&A tool. And we'll also answer questions live at the end of this presentation. So for today's agenda, we're going to start with a really simple demonstration of analyzing data across your data estate using Oracle Analytics. Then we're going to take a look at what's going on under the covers, because that's actually really interesting, because we're going to be doing some sophisticated processing that has made accessing data through Oracle Analytics really straightforward and efficient. We'll then drill down into that architecture. It's called Big Data SQL and Cloud SQL, and how that architecture supports Analytics Cloud. But not just Oracle Analytics Cloud, actually any tool or application that can query Oracle. And then finally, we'll peel back the onion and do a geeky demonstration of how all of this was all set up. So let's jump into the demonstration. And basically, it's how Oracle Analytics is simply accessing a single source, the Oracle database, that's then reaching across all these different data stores. I'm in Oracle Analytics Cloud right now, and I'm actually looking at City Bikes data, right? And so City Bikes is a program, probably if you're from a city, you'll see this everywhere, where you can pick up a bike from one station and ride it to another station, and you just drop it off. It's basically a bike sharing and rental service. And they have the same type of challenges that many businesses have, right? One of the key things is you want to make sure that you have the right inventory, right? The right bikes at the right place at the right time. You want to be able to understand just overall performance of your business. Now, I'm just going to do a really simple demonstration just for a couple of minutes. And what we're doing is we're just starting off looking at a high-level review of the business. How many trips have we taken across all time? How many passes have been sold? And, a daily trend, right, of usage. Well, this is interesting, right? But let's add some more color to it. Let's extend the breadth of our analysis and see, well, how has this performance been impacted by weather, right? So now I'm looking at data by weather, and you can see that, on Monday, people are probably Ubering to work because they're pretty tired after a party-filled weekend. On Wednesday, it looks like perhaps they're more hardcore, right? Interestingly, when it's raining or snowing, we have more people who are riding versus during clear skies. So people are riding their bikes, right? They're doing it no matter what. And if we look on the right here, we can see that clearly temperature matters. If it's cold out and it's clear skies, you're much more likely to be riding your bikes versus, if it's fairly warm, 50 to 75 degrees, the weather itself doesn't really matter so much. So we've just very simply, very simple example of extending the breadth of our analysis. And now I'm going to drill down some more. All right, not only do I want to extend the breadth, but I want to expand the depth of my analysis, right? And look at each of the individual trip details. In this case, I'm looking at it by, for each trip that's been taken, when were they taken? Morning, midday, afternoon? Where are people going, right? Well, it looks like a lot of people are heading to Grove Street, which happens to be a PATH train to New York City, right? So there's a lot of people who look like they're doing commutes, right? They're taking the PATH train. If we look at it by, let's say, a morning segment, we can look at information and say, hey, as a user of this bike system, how long is it going to take me to get from point A to point B? And, well, here's the average trip duration to go to Grove Street from the different stations, so I can help plan my day. If I look at midday, everyone's going to Grove Street, but there's actually something very different here, right? The start station and the end station are actually the same, right? So it looks like, and the duration, instead of just being a few minutes, is actually an hour. Very different use case, right? This is probably someone who's visiting. They come into Newark or to Jersey City. They're taking their bikes and they're riding around for an hour. These aren't commuters, right? These are people who are probably exploring the area. So, if you're having a marketing campaign or something, you may want to look at this a little bit differently based on time of day and where you are, et cetera. So, okay, really simple. Like I said, very, very simple demo. Let's take a look at the architecture and what's going on under the covers. Well, this simple demonstration was actually accessing 3 different data sources, right? So when we were looking at the high-level trends, that was actually coming from an Oracle data warehouse. When we decided to add the weather data, that weather data wasn't actually stored in Oracle. That was coming from the Oracle Object Storage. And then when we drilled down into the detailed trips, that information was actually coming from Hadoop, right? Data that's managed by Hive. So for these 3 different analyses that we're doing, 3 different dashboard pages, information was coming from very different places, and that information was just blended, right? Data from the warehouse was blended with data from Object Store and blended with data from Hadoop. So it's kind of a question is, what does your organization's data platform actually look like? Right? I expect that most all of you have a data warehouse with the following characteristics, right? The data is trusted, it's curated, there's a high level, you have a lot of users who are accessing it through many different types of dashboards. Generally, it's a high performance system with, based on a single subject area. On the other side, you may have a data lake. And that data is a mixture of different types of data, right? Data across multiple subject areas. It could be data of mixed value, data that you can trust, but also experimental data. One of the nice benefits of the data lake is that it's easy to integrate new sources because it has a schema on read approach to accessing that information. So you just load data, start looking at it. So it gives you the ability to have like a fast fail or fast win, right? There's no requirement to create tables, load that data. You just basically load it into the lake and just start looking at it and start analyzing it. On the data lake, it's probably not the greatest platform for fast query performance with a large number of concurrent users. That's what the data warehouse is really for. But it's great for data scientists. It's great for doing that exploration. And it should have acceptable performance. So the question is, like in your organization, are these areas stovepiped, right? And that's oftentimes what we'll find, right? That these platforms are often owned by different teams. And I guess the real question is, what if you could seamlessly blend these sources, right? So if you could extend the warehouse with agility, right? You have new information like data, like the weather data or the detailed trip information. You just want to agilely add that information and make it accessible through the warehouse immediately, right? And then answer questions that are going to correlate data from the warehouse with data that's coming from the data lake. And that's what Big Data SQL and Cloud SQL is really all about, right? This technology, this capability enables you to analyze data across big data stores, right? And the beauty of it is that you can use Oracle's rich SQL dialect. What does that mean? It means that all of your applications will continue to work, right? If your application queries using SQL, and it selects, we're not doing inserts and updates and deletes, but if they're querying sources using SQL, you can now access data from these other sources. So that's really important, right? You get to preserve your existing investment in both your applications and skill sets of users. You also have the ability to provide a unified security model across these sources, right? Because it's very uneven. You might have, if you're looking at in Cloudera, you may not have access to, redaction at the column level. But using Big Data SQL, you can, right? You can apply Oracle security fine-grained access controls to data regardless of where it lives, whether it's coming from Kafka or coming from whatever the source is. And the other thing about Cloud SQL and Big Data SQL is that it's leveraging tried and true Smart Scan, right? This is the technology that makes Exadata excel, right? Analyzing and processing data where it resides in a scale-out architecture. So let's take a closer look at this architecture and what's really going on. So at the bottom of this diagram, right, we have data coming from various sources: Hadoop, Object Store, Kafka, and you also have data in NoSQL stores. You have different applications like Analytics Cloud, or for that matter, any SQL application. You may be accessing your data through Python or through REST calls. And you have your Oracle Data Warehouse. So conceptually, Big Data SQL augments both. There's really 2 parts to Big Data SQL. The first part is enabling your database to be able to reach out to these stores, right? And we'll drill down into what that means. And the second part is a scale-out compute tier. And that scale-out compute tier is responsible for scanning, filtering, applying functions, and aggregating data. So let's drill down into that database tier. Well, the first part of the database enablement is to create Big Data SQL enabled external tables, right? So there's new type of tables in the Oracle database for accessing data in your Hadoop cluster, whether it's using Hive, which has metadata, or HDFS, the Hadoop distributed file system, where there is no metadata, you're literally just accessing files, as well as object storage, right? So now, not only do these external tables access local files, but they can access these other sources, and they can actually access them at scale, and we'll talk about that scalability in a second. Secondly, these tables have access parameters associated with them that enable you to identify and describe those sources of data. So for example, if you're looking at Oracle Hive, what is the table, that Hive table that you're pointing to? If it's data coming from an object storage, what's the bucket? Where is that data being stored? So that's kind of the parameters that you can specify as part of that table in Oracle. Again, the data is not going to live in Oracle. It's not going to be stored there. Oracle is going to query those sources dynamically. And as the data in those sources change, you will get the latest and greatest data. Now, that compute tier is where a lot of the magic lives, right? So the compute tier, in the case of Big Data SQL, is actually deployed to a Hadoop cluster, right? So if you think about a cluster, you may have a 50-node Hadoop cluster. And you have data maybe across the large majority of those nodes. Let's say it's on 50 nodes. When queries are run against the database, you may be running, like an analytics hub may run a serial query against that database. And the database is then going to use what's called fan-out parallelism. In other words, it's going to leverage the parallel processing power of that Hadoop cluster to scan the data locally, wherever that data is. It's then going to filter that data, and it's going to aggregate that data. Likewise, it's going to use that compute tier to access data that's in these other stores. Critically, that greatly decreases the impact on the workload of the database. Right, so drilling down on this just a little bit more, right? What's happening? So when we're running a query from one of these sources against the database, because all the applications are querying the database, and in this case, the data is, let's say, coming from Hadoop, right? And I'm just going to say, hey, I want to look at, what is Peter doing today, right? So that filter, where the customer is Peter and the data is steady, is going to be pushed down, right? So you may have 50 terabytes worth of data in Hadoop. It's going to filter that data. And it's going to say, well, I just want to see Peter. And I just want to see today. And then I just want to see a sum of all of his activity today. So all of that processing is going to scale out. It's going to use that compute. It's going to filter the data and just bring the result back to the database. And there's all sorts of optimizations that take place, including when you're joining data from lookup tables to fact tables, those predicates will be pushed down to the compute for efficient processing. In addition, the database, like with 19C, introduced in-memory columnar processing, right? So now you can do in-memory processing on the database tier for sources to get lightning fast response time against data across these sources. On the compute tier, it also does the aggregation, and we talked about that before. So at the end of the day, it's all about really filtering and eliminating data as much as possible, processing that data and aggregating that data, and then bringing the result back to the database and to the client. So efficient processing. And that data may come from Hadoop, that data may come from Object Store, may come from Kafka, or a combination of these sources for a single query. Now, one of the enhancements, we've talked about always running against the data warehouse, but there's also the possibility to deploy what we call a query server to the cluster. right? So this, you could think of this as being an Oracle query execution engine that's on the cluster. There's no management required. These applications will run queries directly against that query server, again, using Oracle SQL. And the query server is going to use the metadata and the security rules that have been defined in Hadoop without having to replicate them. You're not going to have to create tables or do anything. It's going to synchronize with Hive for that metadata. You could think about this as being a SQL on Hadoop and Kafka and object store solution. It's a zero maintenance database. You don't store data in query server. It's literally a query engine that allows you to access these stores. So now you can run Oracle SQL against all of these sources without necessarily having to go through the warehouse, right? You don't necessarily combine data that's coming from the warehouse with these sources, but you can combine these big data sources together. Now, Cloud SQL is a similar architecture, right? So with Big Data Service, which is a new OCI native cloud service that was released in April, Big Data Service provides a comprehensive data lake platform, right? It's based on Cloudera. It's a native OCI service. It enables you to easily deploy secure HA clusters with just a few mouse clicks. And you can build a cluster to whatever size you need, right? From small development clusters to large data lakes. Now, Cloud SQL, just like we talked about before, that was really the on-prem when we were talking about Big Data SQL in the data warehouse. Here on the cloud, we deploy that same query server, right? So all of these applications can now query that query server directly, right? And you get the ability to query across object store, your data lakes and object store, and data that's in Big Data Service as well. All right, so fundamentally, you could replace the term Big Data SQL in the previous slide with Cloud SQL, and that's really what we've done. And we've taken the database out of the picture because we're using the database query engine here running on your Big Data Service cluster. What's coming, right? Well, actually, let's start with what's today. And with Autonomous Database today, remember I mentioned there's two parts to Big Data SQL and Cloud SQL. There's the database enablement, and that's been done with Autonomous Database today, right? And that's what allows Autonomous to be able to access object storage, right? So today when Autonomous Database is accessing object storage, it's using the database component of Cloud SQL. What's coming with Autonomous Database is to also leverage that Cloud SQL compute tier. What's different, and what you'll notice is there's no Hadoop necessarily in this tier, right? So this is a serverless Cloud SQL compute tier that Autonomous will use. So effectively, you'll go from, one day you'll be running queries with Autonomous against object storage, and then one day it's just going to get more scalable and faster, right? Because it's going to automatically use this Cloud SQL compute tier to scale out queries against data that's living in the object store. And that's activated when Autonomous Database autoscale is enabled, right? So that's what's coming down the line. Let's see what's going on behind the scenes. Okay, so we're in SQL Developer. And, this is really the back end of what we saw in our first demo, right? So remember on that first page, we said, hey, I want to look at ridership, right? So this data, the daily ridership, the number of trips, et cetera, this is actually coming from an Oracle database. But then we want to say, well, let's add more color to it. Let's add the weather data. Okay, well, in Oracle Object Store, when I go to Object Store, I'm actually looking at object storage right now, and here is the weather for Newark International Airport for all the days of the year. And so the question is, how do you make this available for query? So I'm going to go back to SQL Dev, and I'm going to create a table called weather with my columns. And it's actually pointing, and notice it's using this Oracle Big Data driver. And it's saying, yeah, I'm going to point to this data that's living in the object store. That's the location. It's actually a text file that's delimited, and it's got a header. And I'm going to create this table, and I'm going to query it. I didn't load any data. I'm just accessing this data now this mess is now being accessed through the database or through Oracle Analytics Cloud. And now I just start running queries, right? I have data coming from weather, that weather table I just created, and data coming from ridership. And I just run my queries and I can say, yeah, well, when it's 32 degrees and below and clear skies, here's the number of trips that were taken. And frankly, when you're running this query, do you know where the data is coming from? You don't, right? Some of the data just looks like a table, right? I have ridership. Well, that I know happens to come from the database because I remember. Weather happens to be coming from object store, but that's because I just created it and I knew. But as a user or as a tool or an application, it doesn't matter, right? You're just accessing data, and the database is responsible for understanding, the data is coming from the object store, and I'm going to query that at scale. Well, you know what? I also have information about stations, right? This station data is actually coming from HDFS. That's the Hadoop distributed file system. And I look at that, and here now I'm in Hadoop, and this is a mess, right? This is actually JSON data that we pulled, and it has information about the station and its ID and the name of that station and all this. It's pretty hard to query, right? And the database actually has tremendous capabilities for parsing this. So I'm going to go back to SQL Dev, and I'm going to create a table over that source that's coming from Hadoop, like stations, and now I'm going to query it. Right? I have a single column called doc representing each JSON record. And if you look at the result, this happens to look just like this, a little messy. But now you notice we have things like Oracle SQL saying, well, pull out the name attribute, the short name, the longitude, the latitude. And if I scroll to my right here, that mess is now highly structured, including the name, the latitude, the longitude. This is all you needed to do in Oracle SQL. Oracle SQL has a native understanding of JSON, which is very cool. So you're taking something that's very complex and making it easy, right? And if you want to now load this, and you don't want to query JSON all the time, right? So if you just want to do a quick ETL process, well, I'm going to create a table called stations, and now I'm actually storing that data in the Oracle database in a better format, right? And now the last thing I'm going to do is, well, I have all of these trips. Remember, what is every single trip that people have been taking? The trip duration, the start time, the start hour. This is actually coming from Hadoop. And it's coming from something called Hive. And Hive has metadata. And the name of that Hive table is called trips. So we're going to create a table in Oracle pointing at that trips data. And now I can say, well, let's look at trips. Right? And let's see what are the most popular stations. And I'm going to use Oracle SQL to say, hey, let's look at the approximate ranking, right? This is some of Oracle's capabilities to say, well, I don't necessarily need the exact rank. I'm just trying to understand my data a little bit. And I can see that Grove Street is by far the #1 station. Hamilton Park is second, et cetera. Right? And I'm now querying that data like I would any other. And you can continue, right? Now I'm just querying trips. Let's find all bikes that have been on trips that were less than a couple minutes. The reason why I might want to look at this is if I'm on a trip that's taking less than 2 minutes, maybe there was something wrong with my bike, right? I took the bike out, I tried to use it, it didn't work, I put it back. Let's take a look at these bikes and maybe bring them in for proactive repairing, right? Again, just being able to look at data that's outside the database and blending it with data inside the database very easily. So that's Big Data SQL, right? And that's Cloud SQL. Being able to use Oracle advanced SQL capabilities against data that resides anywhere, right? And you saw it, how it makes Oracle Analytics simply access a single source, and a lot of the complexity is now pushed down, right? And you have all of that efficient processing against these sources. You get to leverage Oracle security, Oracle SQL, the skills, it all just works, right? It's very, very simple. So that's Cloud SQL and Big Data SQL. I just want to thank you very much for joining. Please feel free to ask any questions and we'll answer them now.